Hello everyone, welcome to our channel CodeChef. This is Kusmulata Bhatt and today we are going to solve the problem array swaps from CodeChef platform, which is of simple difficulty level and it requires no prerequisites. So let's have a look on the problem statement first. Salmon received an array A of size n and an array B of size m for Christmas. He would like to move all of the elements in B to A using a special method described below. While B is not empty, Salmon does the following operation in order. Remove and store the leftmost element of A. Let's call this element X. Place X at the start of the A. Keep swapping X and the element to the right of it repeatedly until X is at the rightmost position of A or X is greater or equal to element to the right of it. Before performing the operation, Salmon can rearrange both A and B in any order once. He would like to do as little work as possible. Determine the minimum possible amount of swaps. So we are given with an array A and B in which we have to put all of the elements of B into A using a procedure in which we are going to take the leftmost element of B and then we are going to place it in A from the left hand side and we are going to swap it with the elements of A from the left until it becomes greater than or equal to the adjacent element or it is at the rightmost position of A. Now there is a thing in the problem that we can rearrange this A and B as per our choice, but after rearranging we have to make sure that the number of swaps we are getting in placing all the elements of B in A is minimum. So this is what we have to do in the problem. So let's have a look on the input format first. So here the first line of the input is going to contain N and M, where N and M is the size of A and B array respectively. And then we are given with A and B array elements in which A and B element can lie in the range of -1e9 and 1e9. Now for the output, we have to print the single integer which is going to give us the minimum number of swaps required. Now there are three subtasks in it, in which first subtask is all of the A value is 1 and all of the B value is 1. The second subtask is N and M value is smaller than or equal to 10 to the power 3 and the third subtask is the original constraints. So let's see how we can solve this problem. So let's see the subtask 1 first. So in the subtask 1, we know that our A array is going to be look like 1 1 1 and B array is also going to look like 1 1 1 and 1. So there can be any amount of 1 but all of the elements of A and B are going to be 1. So this is our first subtask. So in this we can see that when we will place 1 in the left of the A, then we are not going to do any swap because it is already greater than or equal to its adjacent element. So when our A and B elements will be same, in the first subtask it is 1, but for the general case, let's say our A has the all equal values as A and B also has those values as A, then in this case we are not going to do any swap because we are going to have our condition satisfied when we will be keeping the element of B in the left of the A, that is that element will be greater than or equal to its adjacent element. So in this case the swaps we are going to have is 0, so that is the minimum only. So let's solve for the case when all of the elements are not same. So in this, let's see what can be the optimal arrangement of A. So in the case of optimal arrangement of A, what we will be keeping? We will be keeping the smallest element at the first position only. So what our approach will be? We will be keeping smallest element at first. Now why so? So for this, let's consider the case in which we are not keeping the smallest element first. So let's say we have an array 5, 3, 1, 2 and 4 and we have to keep B element. Let's say it only has one element for now, that is 4. So now when we will be keeping 4, so we can see that first we will keep it at the left of the A array and then we will be swapping it with 5 as 5 4 and then we will put it here. So we can see here that we are wasting extra move here by swapping it with 5 because what we can have, we could have put the one element or three element first and then this 4 element would have adjusted here only. So from here I can conclude that if I am putting some element y first, and minimum element after that, then I am going to waste my swaps for those x elements of B which are in the range of y and minimum. So all of those x will be wasting our swaps. So from this, we can conclude that we are always going to keep our minimum element at first. So we are clear with the fact that we are going to place the minimum element at first in A. Now there is also one thing which we can notice here. If our element x is getting swapped with the minimum element of A, so this means that x is smaller than min. Only then we are swapping x and minimum element. Now if it is smaller than min, then it is smaller than every element of A. That is, the position of x in the A array will be at the last of the A array. For example, let's have A as 1, 2, 3, 4 and 6, and we are keeping B element as -1. So we are saying that -1 is smaller than 1. So we can be sure that it is going to smaller than every element of A, because 1 was the smallest element of all, and when the number y is smaller than the minimum element, then it is going to be smaller than all other elements. So this gives us fact here that when we will be putting some element x, if it is smaller than minimum element, then it is going to take the n steps and swap for getting to the last of the array A. Now this was the case when we have one element in x. Now let's see for the case when our B is going to have multiple elements. So for this, we can make sure that our B is also sorted in increasing order. Because by sorting our B array in increasing order, we can be make sure that if we have x and y element and B, and x is smaller than y, x is smaller than or equal to y, then y element is not going to take more swaps than x, because it is always going to get stuck of x, because we know that y is greater than equal to x. So at some point in A, it is always going to be stuck at the left of the element x. So this will be optimal for us to sort B in increasing order too. So from here we are sure that the first element of the A array is going to be minimum, and for the B array we are sorting all of the B element in the increasing order. So from here what we have to count is, we have to count all of the elements which are smaller than minimum in this B array, and only those elements are getting swapped. So our answer is simply the number of elements which are smaller than min, and we are sure that who are smaller than min are going to be placed at the end of the array. So they are going to take the n swaps exactly. Now let's have a look on the C++ implementation for the problem. So here we are assigning our answer as 0 and we are storing it in long variable, and then we are taking the input for the size of A and B array, and we are initializing our minimum as 2e9 because we have the values in the range of -1e9 and 1e9 only. So we can simply initialize our minimum as some large value. So we have taken 2e9 here, and then I'm declaring my A and B array. Then I'm taking the input of A array, and on the simultaneously side I'm finding the minimum of the array. Then I'm initializing the CNT variable, and I'm taking the input of B array, and at the same side I'm calculating how many elements of the B array are smaller than this minimum, and I'm incrementing this count, and then I'm simply assigning CNT into n as my answer, and I'm printing answer to the screen. Now what we can have here is, we could have avoided the use of arrays, and we could have simply taken the variable here to reduce the space complexity, but this way will also work fine. So let's run it on the given test case. So the answer is 5, which is correct. So on submitting, let's see whether it passes the all test cases or not. So we are getting the correct answer for all of the input test cases. Now let's have a look on the Python code. So here I am taking the n and m as the size of the a and b array. Then I am taking the a and b array as the list in Python. And I am simply finding the minimum in the a array by using the min function of the Python library. And then I am initializing my count as 0, and then I am simply traversing over the list B, and I am checking how many elements in this B is smaller than the minimum of A list, and I am incrementing by count whenever I am encountering an element which is smaller than the minimum of the A list, and I am simply printing CNT into N to the screen. Now let's run it on the sample test cases. So here I can see that I'm getting the same output as in the sample output. So let's submit it and check whether we pass all of the test cases or not. So we are passing all of the test cases and getting correct answer as a verdict. Now let's have a look on some of the common mistakes which we can have in this problem. So one of the major mistake which we can encounter in this code only is we are not using the right typecasting here. That is, we are not applying one LL while we have taken CNT and N in the end. So what it will do, it will result in the overflow while calculating this value only. So we have to make sure that we are using the right typecasting method. The other way can be we are initializing the CNT as long also, then also it could have prevented this overflow. The other thing can be in understanding the problem, that is missing out the condition of greater than or equal to, or interpreting it as the greater than only. So we have to make sure that we are reading the problem statement and applying this condition rightly. So that's it for the video guys. Thanks for watching.